Hello, and welcome to the 2024 Commodore 64 Repair-a-thon on yet another retro channel. This is part 5 of the Repair-a-thon. If you haven't seen parts 1 through 4, I recommend you go ahead and watch those before you watch this one, as we'll be using some of the information that we gained in those first 4 parts to help us with this part. To watch those, you can either look in the description below, or I will post a link up in the corner. And now we're ready to move on to machine number 8. It's in relatively good shape. It's quite dirty. There's no significant yellowing. There's some blemishes and marks here and there. It is missing its 3 screws from the case. And we do have a note saying power light and black screen. So that's what we'll be looking for as a symptom. So we're going to go ahead and hook this up. The power light is on as reported on the note. However, we are getting no video output whatsoever. So we might have another VIC-II problem. Other issues that can cause that are no power coming from one or the other of the internal regulators, fuse being blown, the VIC-II of course, and if this is one of the later boards, possibly the 8701 clock generator. So let's get this thing opened up and see where we stand. As I said, there are no screws, so it's going to be simple to pop the lid off, pull the keyboard and LED connectors, set the keyboard aside. Now, as you can see here, we do have a 250425 board. Nothing looks particularly out of place. There's some, dirt, obviously. Thermal paste on top of the bridge rectifier. So let's go ahead and get the shield off. We are missing some screws internally as well. So someone's definitely been in here. Only 3 of the 4 screws holding the shield in place. No, 4 of the 5 screws, I should say. But one of them, this one, was stripped out, so I'm guessing that standoff there is damaged. So we'll set the shield aside as well. And we have a ton of sockets in here. We have an R8 VIC chip. We have a standard 6581 SID. We have an old 82S100 PLA. That's going to be likely good then. Most of these chips are 84. So I'm guessing this machine was made in 1984. And we're missing 1 RAM chip. And we have 1, 2, 3, 4 MT RAM chips. 2 MOS logics here, a MOS logic here. Alright. Let us start with testing some voltages. Like I said, one of the things that can cause that is incorrect voltages coming from these 2 regulators. We will check continuity on the fuse and make sure that's good. And it is. And we will then switch over to DC voltage and check our 5-volt regulator. That's good. And our 12-volt regulator, that's good. So we're getting good voltages there. We're only getting 4 volts at the user port, so there's a good chance there's a short somewhere. And check our AC voltage. 10 volts at the user port, that's good. So, next thing to do, so we've got our voltages. Normally you would expect at this point that the fault would be with the VIC-II. However, since this is one of the later boards with the simplified clock circuitry, the 8701 is actually a likely candidate to be a problem. So I am simply going to switch this 8701 out with a known good one. I can get it out of here. And we'll see if that's why we're not getting any video. We'll check that before we pull the VIC-II because it's a simple test, and we'll see what we get. So let's look and see if we get any output. We do, but it's a black screen. So odds are the VIC-II is working fine. And this 8701 chip is dead. Now, the next thing to do is put a new RAM chip in the socket, in this empty socket. I just need to grab a tested and working 4164 chip. It has a check mark on it where I've previously tested, and I should be wearing my wrist strap. You'd think I would learn those lessons. The ROM chip, or the RAM chip, in place. Let's see what we get now. Well, we get more than we did before. We get garbage on the screen. So at this point, I think dead test is a good option. Okay, so I have my diagnostic cartridge set to dead test mode. And let's see if we get anything. Well, no flashes, but no nothing. So we definitely have something bad in here. Now, the next test I'm going to attempt is I am going to remove the unnecessary ICs. Dead test only requires the CPU, the PLA, and the VIC-II to run. So the SID, the 3 ROMs, and the 2 CIAs can be removed. And for those of you who are screaming that I was supposed to check the reset signal, you are correct. So I'll do that on this next boot up. But since we were getting something, I believe reset is going to be good. And that is pin 40. Reset should stay low for a moment and then go high when I switch it on now. And it does. So our reset signal is good. Now, back to the output, and let's see if we get anything on dead test with all of those chips removed. We do not. So, we have something else failing. Let me check real quick if pulling those chips improved our voltage level at the user port. We're up to 4.6, so that did improve things a bit. So probably one of those chips has a problem. Now, our next suspects, normally I would look to the PLA. However, as I said, this is an 82S100 PLA. These were very reliable. So our next suspects actually are going to be our MT branded RAM, 4 of those, 5 of those, and the MOS logic chips. This one, and this one. Let's feel for any hot chips. Let's leave that running for a bit. Nothing is feeling particularly hot, but we'll give it a little more time. Okay, nothing is getting unnaturally hot. So, what I'm going to do at this point is I'm going to pull the MT RAM chips. They may be the most likely suspects. And we're going to bring up the ZIF board. And we're going to test all the chips we've removed at this point. So, dead test on the ZIF board with nothing changed out. Okay, so the ZIF board with all of its original chips passes everything. Let's go ahead and start looking at the chips from the test board. I don't really need to test the SID right now, but we'll go ahead. Now the SID isn't killing the board. Let's see if it makes any sound. Well, it sounds marginal, so we're probably going to have to replace that as well. But for now, marker with an M. Now, as I said, the PLA in that machine is an 82S100, which makes it a very reliable PLA, but I would be remiss if I didn't check it. Interesting. No, it's working. Just wasn't seated well in the ZIF socket. So the PLA is good. As expected. The character ROM. Okay, Character ROM. And to test that, I need to take the dead test out. Character ROM is good. Kernel ROM. Kernel ROM may be bad. Make sure we're seated well. Kernel ROM looks bad. Okay. And basic ROM. And basic ROM is good. First CIA. Flashing cursor looks good there. We'll do a more in-depth test on the CIA later, but for now, looks good. And the second CIA looks good. For now, like I said, we'll do a more in-depth test with the full diagnostics later. So, we're going to need to replace the PLA. Memory. MT RAM chips. All the MT RAM works. Let us see if our problem was solely the PLA. Let's get our confirmed good MT RAMs back in here. Now, of course, before I let this board go to anyone, I will replace these MT RAMs and not sell these problems on to someone else. Okay, and then PLA. No, PLA goes in here. And what does dead test give us now? Oh, now we're getting flashes. 2, 3, 4, 5, 6, 7, 8. 8 flashes. Okay. According to the dead test manual, 8 flashes identifies U21, which is this IC right here. This is the one that I replaced with what, as far as I know, was a known good chip. So let's try replacing it again and see if we get the same result. And we have another supposedly good tested 4164. One, 2, 3, 4, 5, 5. 2, 3, 4, 5. Okay, this time we're getting 5 flashes, which is U10. U10 is this MT RAM chip. Are we consistent? Let's try bringing that up again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this time we're getting 8 flashes. All right. At this point, I begin to suspect the multiplexers, since these are both MOS logic chips, and those those should be 74 LS257s. Let's go ahead and pop these out. I'm doing both because I've been told, and I don't know if this is true or not, but usually if one's bad, both are bad. And it's always good to get rid of MOS logic chips anyway. So I'm going to pop both of these. Grab a couple of 257s. And if this fixes the problem, I will check those in my TL866 and see if one or both of them were bad. Those are not in there with sockets. Wow. Okay. I don't like that at all. Those are in. I don't know if you can see that. I'll bring this up to you. Those are just in there with what look like the guts of a socket, without the socket itself, without the plastic part. So any of those could be bridging. Let's take a look and make sure before we put anything in here. Don't see any bridges. I'm going to try putting these in here. I'm probably going to want to replace these either way with proper sockets. And what do we get? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that didn't fix the problem. Well, there's another MOS logic chip we can replace here. And this one is, I think, a 130. Oh no, that's the 08, 74 LS08. So let me go ahead and grab one of those real quick. One, 2, 3, 4, 5, 6, 7, 8. Still 8. Very consistent now. And it is still possible that I've got another bad or incompatible. Let's try something else for that. I have some newer 4164s, or not newer, but a more recent purchase of 4164s than the ones I was using there. So let's try one of these. Okay, now it's saying 5 instead of 8. And doing it consistently, so which one was 5? I think it's U10. Yeah, 5 is U10, which is him. So take a flyer that that's the problem. One, 2, 3, 4, 5, 6. 6 this time. Okay, let's try it again. 1, 2, 3, 4. No, 1, 2, 3, 4. 1, 2, 3. This time it's 3. Okay. What I want to do, I'm going to go ahead and replace all the memory ICs that I haven't replaced yet, including the MT RAM that tested good in the ZIF board. Okay. One flash. One flash is U12. Still one flash. Okay. So I'm betting at this point all the RAM that I have in there is good. There's one other chip that could be the issue, so we will take a look at it. The CPU could be the problem. Is the CPU good? Yes, it is. All right then. We are going to need to dig deeper. Okay, now I didn't check the clock on the CPU, so let's check that. And that is a good 1.02 megahertz, so the clock's fine. Okay, I've gone to the trouble of pulling the board out of the bottom of the case and removing the bottom shield. And I don't know how much you're going to be able to see in the camera, but the amount of rework done on this thing is astonishing. Almost every chip at the bottom of the board has been pulled and the socket put in its place. And it looks like the main MOS ICs were never touched, but the multiplexers, all the RAM, all this glue logic has all been replaced. Now, the work doesn't look terribly bad, but frankly, well, first of all, we have these two multiplexers, and those, instead of proper sockets, they just had the pins. I don't know how much you can, well, you can see that. They just had the pins in there. No plastic frame for the socket, just socket pins. Looks like dual wipe pins, but nonetheless not great. So I'm pulling all of those out. The other sockets that were put in, especially for the RAM, are crap sockets. These are single wipe. These are bad quality single wipe, bad quality single IMA. These need to go and be replaced. So all of those are going, all of those sockets are going. This socket is double high. I don't know, I don't know what's the deal there, so I'm going to replace that socket. And then I'm going to examine the other sockets and see if there's any damage or any reason to pull them. The only one that I've seen so far that's a double wipe is the 7408, which we replaced earlier. That's a double wipe socket, so that's likely to stay where it is. But the rest of the sockets I think are going to go and be replaced. So that's what I'm working on right now. Okay, so I'm still in the process of removing the crap sockets, and I'll eventually replace them. But I wanted to take a minute to show you what I've been finding. Now, I've removed 5 of the RAM chips and the pin sockets that were made for the multiplexers. And in that process, what I've been finding, the top of the board, as you can see, is relatively okay. However, there is some of what I'm talking about. If you look at pins 8 and 16, you'll see there is some damage on this chip. Most of the others on pin 8 are relatively okay, except on this guy right here. But if you look up at pin 16, you will see that a lot of the solder mask around those is gone. And I didn't do that. My guess, and if you look at the back, it's even worse. Let's see, where are we looking here? If you look at the back, you'll see that that removal of the solder mask is even more extensive. What I'm guessing, and I'm not sure about this, I may be wrong, but my guess is that the person that pulled these chips originally and resoldered them, or soldered in the sockets, was using a soldering iron that wasn't hot enough, and as a result, he had to linger longer around those pins, and probably had to do rework after he got the chips out around those pins to clear away the old solder. And what he's done as a result of the soldering iron being too cold and having to stay on them longer is that I believe he burned away the solder mask around there. Now, that may or may not be part of our problem with this board, but I'm going to have to be very careful when I solder new sockets in. I may, in fact, even go ahead and apply some UV curing solder mask that I've got to help protect these from bridging. That's the issue we can have here. Because the solder mask is not where it's supposed to be, you can have bridges more easily. So I have tested these so far, and with the sockets removed, I'm not seeing any bridges or and I've also tested continuity with your memory chips on the C64. Pins 1, 2, and 14 do not go to every chip, but all the rest of the traces should be common among all 8 memory chips. So 3 through 13 and 15 and 16 should be common among all the chips. So I've gone ahead and using my multimeter in continuity mode, I have tested for that, and I have tested for bridges between the pins, and so far I'm not seeing any. So, like I said, it's a good idea to get rid of these crap sockets, so I'm not bothered by the fact that I'm doing this possibly for no immediate purpose. It's possible that that this won't change the issues we were having with the board. Now, I did also pull each of the logic chips. What you see down here, what you see here is the sockets for the two 4066s. Those are out at the moment, but the rest of the chips are back in. I did find a couple of more logic chips that did not test right in the TL866 Mini Pro, so I am replacing those, and hopefully between getting rid of these crap sockets and those few chips that were bad, there was a 4066 was bad, The original 74 LSO8 was bad. We've already replaced that though. And the original multiplexers, the MOS logic multiplexers, were both good. However, they're not going to go back in the board because they're MOS logic. And of course, the 74 LSO8 was a MOS logic chip, and it was bad. So between those and the ROM, the kernel ROM that was bad, hopefully replacing all these sockets and putting in good logic chips will get this board back up and running. So I'm going to get back to desoldering everything on here, and then install fresh new sockets and be very careful with my soldering, and possibly, like I said, add some solder mask to help keep things from bridging. We'll see you later. Okay, I want to show you something I found while removing sockets, and I don't know how well you'll be able to see this. Do my best. When I removed this socket here, I found a ripped trace. And there was a bodge, but it was bodged with bare wires, so that wasn't going to be particularly successful. So that will have to be repaired before I can put the new socket back on. Well, I honestly don't know where I left off, so let's give you a recap. I have removed the sockets from all the memory and all these logic chips down here and replaced them with brand new double wipe sockets. I went through and tested all the chips that I pulled out to do that. In the process, I found a couple of more logic chips that were bad. One of the MOS logic chips, and I guess these are, well, one of these is MOS logic and the other is an NEC chip. All three of these tested bad in the Mini Pro, so I replaced them with brand new chips and tested those when I put them in. After I put in the sockets, I went through and tested for bridges and tested to make sure that everything was connected through where it was supposed to be connected through to. So in theory now, all of this is good in this section down here. Now again, we have replaced the PLA, we have tested the 6510 and it is good. We have the SID pulled, the SID was marginal, and what you see up here are the bad chips, plus these 8 chips are the MT RAM memory chips. All of them tested good in the ZIF-64. However, knowing their reputation, I decided to not put them back in, and I replaced them with brand new, or not brand new, but I replaced them with good tested non-MT RAM chips. It turns out the two multiplexers, the MOS logic multiplexers that were in here, both tested good. But again, I'm not going to put those back in because those MOS logic chips are so prone to error. So what you see here is the stack of sockets that I pulled. I also ended up pulling and replacing the 24 pin for the kernel ROM. It was not in good shape, so I pulled it and replaced it. And I think we are ready now to try the dead test and see where we get. Hopefully we will get past the memory test and the flashing screen and get into the actual test itself. So let's put in the dead test cartridge. Let's see where we are with the dead test. Hopefully that fixed the problems we were having with addressing. Because we did, like I said, I did find bad logic chips up here. Ooh, 5 flashes. Well, maybe we have some bad memory. Let's make sure this is consistent. flash. Two flashes this time. Okay. We're still where we were. All right. I'm willing at this point to assume, at least for purposes of troubleshooting, that all these chips and all the new sockets are correct, and all the connections going through to where they're supposed to go to, no bridges, because I did test for all of that. Let's look at some signals. That inconsistent RAM failure screams to me that it is the address lines that are the problem, the address bus. So 1, 2, 3, 4, 5, 6, 7. So address line 0. That actually looks good. Address line 1 also looks good. Address line 2 also looks good. 8 again looks normal. 9, oh, that's not good. 9 was good for a while, and then it went to all high. That's not good. So there are things down here that are on address line 9. But you know what? I have a sneaking suspicion. If you remember right, when we first tested this board, we had no video whatsoever. And to fix that, I replaced the 8701 clock chip. We got video. It was garbled video, but it was video. So I made an assumption I probably shouldn't have made. I assumed that the VIC-II was good. It's entirely possible. It would be rare for both the clock chip and the VIC-II to be bad at the same time, but there's nothing saying it couldn't happen. And I never tested the VIC-II independently. Now the VIC-II is responsible for DRAM refresh, among other things, of course, video and the clock, but it handles DRAM refresh. If an address line on the VIC-II were failing, it would fail to properly refresh the DRAM, and we would probably get a random failure each time, because it would simply depend on how long each individual little microscopic capacitor takes to discharge enough to change its value. If the DRAM refresh isn't working because the address line here isn't working, that could easily cause our fault. So, God, did not want to lose another VIC-II. Let's see though. Maybe this is good. Maybe that's not the problem. But it would explain what we're seeing. And it would also explain why replacing all of this stuff didn't fix it. So I'll just leave that there. I won't need that to test with the ZIF board. So here's the ZIF machine again. And we will power it up and make sure it's still working correctly. And it is. So the ZIF machine is fine and all of our connections are fine. Now, pull out our VIC-II, put in the suspect one, and what do we get? We get a black screen. Let's make sure I have it seated properly. Still black screen. One more try. Still black screen. We've got a defective VIC-II. Just put the original VIC-II back in the ZIF board and make sure. Yep. Well, damn. Okay. Well, doesn't that just beat all? So this guy is bad. After all, put that up in the pile of bad chips and get one of my limited supply of replacement VIC-IIs. This one was tested and was good at testing time. We'll hope it still is. And that I don't do any damage putting it in here. Okay. Let's see what happens. Now we still have the dead test in, so look for those flashes for bad RAM, or look for it to go into the dead test. And okay, no flashing. Hey, we're in dead test. Well, we'll let this run through, see how far it gets. Remember, we have no SID in here, so we're not going to get any sound. We also have no CIAs, which is why you're seeing the time of day clocks at the bottom being all confused. Okay, it's past dead test. All right, let's repopulate the rest of the board, and then we will run main diagnostics. And for now, we will pop in an ARM SID. This will probably actually end up with a SIDKIC Pico in it, but I don't have one built up at the moment. We'll use the ARM SID for testing purposes. And that's everything restored to the board. Switch into standard diagnostics mode. And get the harness. And before I do this, however, I am going to give the cartridge or the cassette and user port a clean, because that can cause errors you weren't expecting for no reason. So I'm just going to use a fiberglass pen here. recently saw a video of someone else who had used a fiberglass pen and he got a little fiber stuck in his finger, a splinter, and decided he was never going to use a fiberglass pen again. I think that's a little excessive maybe, but to each his own. I like the fiberglass pens. A little IPA on a cleaning bud to finish it off. There we go. Now the bottom side of those, I believe, is mostly ground or all ground, so I don't think it's necessary to clean it, but I'm going to do it anyway. The reason I say I don't think it's necessary is if they're all ground, or most of them are ground, all you have to have is a connection on one or more of them. So cleaning everything off like this may be overkill. And of course, every time you do it, you take a chance of rubbing off some of the gold contact. All right. A little cotton bud that's still wet with IPA. Yeah, got quite a bit of dirt off those. And now the harness. Alright, there's the harness fully installed. Power and video. And let's see what we get. Cross your fingers. Okay, the diagnostics are running. All right, well, there you go. One more repaired C64. This one was a bit of a costly one. So we had bad VIC-II, bad PLA. Oh, that was the bad PLA. That was the bad kernel ROM. Marginal SID. 3 bad logic chips. The bad 8701, which I don't seem to see up here anymore. We went ahead, like I said, and replaced all the MT RAM and the remaining MOS logic chips. Wow. Okay. But in the end, we got it working. I was going to try to do machines 8 and 9 today, but I think as long as it took to get to the end of this one, I just don't think I have, the video would run way long if I tried to do number 9 before putting this video out and doing one more. So there will at least be part 6 coming. And I think that will do it for today. Thank you all for watching. I hope I didn't annoy any of you with any of the things I did. I know I don't do everything exactly right, but I get the job done in the end. So, if you liked the video, you know what to do there. If you didn't like the video, you should know what to do there too. I appreciate the likes, and I understand the dislikes, so if you feel that's necessary, go ahead and do that. Leave me a comment in the comment section below. I do love to hear from you guys. I do love to interact with you guys. I'm sorry I haven't been putting videos out as often lately as I used to. Got some family health issues going on right now. Some of you know something about that, but I will try to get more out in the near future. I do have a lot of plans, a lot of stuff I want to get to. Share the video out to your friends, to your user groups, to your social media groups. The more people that watch this, the better. That helps the channel, and it helps move me along in the YouTube algorithm, and helps get the videos shared out to more people by the YouTube algorithm. If you want to become a supporter of the channel, and my supporters' names are showing up on the screen right now, there are several ways to do that. You can become a member by clicking on the join button, which is down here somewhere. You can become a channel member. You can also support me through Patreon. Link for that will be in the description below, or Ko-Fi. I also have a Ko-Fi. You don't have to do that. Again, I always say it, you know, no one's required to become a member or become a supporter to watch my videos. There will be a video, a perk for my supporters coming up. I believe it's going to be machine number, I think it was machine number, the machine that had the massive short across everything. We'll have to find where the remaining shorts are, get every short off that board before we even try to repopulate, and then I'm going to try to repopulate that with all new technology parts. So I have a couple of JCIAs, I have Mark from the Retro Channel's ROM replacements, I have a JCPU, of course I have an ARM SID, or I might put in a SID Kick Pico. I have Plankton EV, so I can replace the PLA with a new technology chip. I have a VIC-II Kawari. I don't know if I'll use the large board or the Kawari minis. So all the old MOS chips will be replaced with new technology. Now they won't stay in that board, because I do intend at some point to make as much as possible an all new C64 build. I know that's been done before, but I am involved in a couple of Kickstarter campaigns, one for new breadbin cases and one for a new keyboard. So once I have those, and I'll get probably one of BWAC's. I like the 250407, so I'll probably go with the 250407 replica, have one of his boards made, and build myself up a brand new Commodore 64 with all new parts. That'll be something later, but like I said, there will be a members only video coming where I take that board that had the shorts all across it, like it had a power surge from a bad power supply, and we'll build that back up and get it running with those new technology parts. And I can't think of anything else, so I'm going to go ahead and say goodbye. I hope you all enjoyed this. I hope you all have a great week. Hopefully I can get another video out to you before another week's up. We'll see. But be healthy and stay safe. And we'll catch you on the other side. Thank you all for watching. Bye.